Hi all, I am here with my new video on formulas, equations and chemical reactions. Let's start. In this video we are going to learn about chemical equation and classification of chemical reactions. A chemical equation provides recipe for carrying out a chemical reaction. Example, methane gas reacts with oxygen gas and converts into carbon dioxide, water and heat. So how to write a chemical equation? Methane gas reacts with oxygen gas to produce carbon dioxide gas and liquid water and heat. Let's write a chemical equation for this. First of all, we write a word equation. Methane gas plus oxygen gas, arrow, carbon dioxide gas plus water plus heat. Methane and oxygen are here reactants and carbon dioxide, water and heat are products here. An arrow separates reactants from products and the phases of the substances are included in parentheses. For solid S, for liquid small l and gas small g is used. We replace the name of each substance by its formula. CH4 gas plus O2 gas, arrow CO2 gas plus H2O liquid plus heat, and that is our chemical equation. How to balance a chemical equation? All the chemical equations must obey three conservation laws: conservation of mass, conservation of energy, and conservation of electric charge. That means that the total mass, energy, and electric charge of the reactants must be equal to the total mass, energy, and electric charge of the products. Now we learn how to balance a chemical equation. When we inspect the equation CH4 gas plus O2 gas, arrow CO2 gas plus H2O liquid plus heat, we find something wrong with the equation. The number of hydrogen atoms and oxygen atoms are not equal on the both sides. To correct this equation, we use coefficient. Coefficient is a number that is placed before a substance to indicate how many units of the substance we need. Now we proceed to balance the faulty equation. First, we drop the heat term since it will not play a direct part in what we do. We have 4 hydrogen atoms on the left, so we must produce 4 on the right. Since hydrogen atoms is only in H2O, so we need 2 H2O to account all the hydrogen. Now our equation will be CH4 gas plus O2 gas, arrow CO2 gas plus 2H2O liquid. This equation is balanced for hydrogen. Now we count the oxygen atom and find that on the right we have 4 oxygen atoms, 2 from carbon dioxide and 2 from H2O. We can easily produce 4 oxygen atoms on the left side by using 2O2. And now our equation will be CH4 plus 2O2 arrow CO2 plus 2H2O. And this is our balanced equation, means an equation balanced with smallest whole number coefficients. Chemical reactions are classified in 4 types of reactions: synthesis or direct combination reactions, decomposition reactions, single replacement reactions, and double replacement reactions. Synthesis reactions. In this category, reactions in which 2 or more reactants combine to produce one product are involved. It can be written in this form: X plus Y, arrow XY. Example, Fe solid plus Cl2 gas, arrow FeCl2 solid. Decomposition reactions. A decomposition reaction involves the breakdown of a single reactant into 2 or more products. It can be written in this form: AB, arrow A plus B. Example, 2H2O2 liquid converts into 2H2O liquid plus O2 gas. In a single replacement reaction, an uncombined reactant replaces another element that is part of a compound. It can be written in this form: C plus Ed, arrow Cd plus E. Example, zinc solid plus USO4 aqueous solution, arrow zinc sulfate aqueous solution plus copper solid. Single replacement reactions occur only under certain conditions. For example, the replacement of zinc by copper, the reverse of the reaction will not occur. Since zinc replaces copper from solution, it is said to be more active metal than copper, means zinc will form a positive ion easily than copper will. Double replacement reactions. In a double replacement reaction, two elements in different compounds replace each other. It can be written in this form: PQ plus RS, arrow PS plus RQ. Example, when barium nitrate in aqueous solution reacts with sodium sulfate in aqueous solution, converts into barium sulfate, which is solid, and sodium nitrate, which is also an aqueous solution. Double replacement reactions also occur under certain conditions. At least one product must form a solid known as precipitate, a gas, or a molecular compound. Above reaction happens because a precipitate of BaSO4 barium sulfate forms. Please like and subscribe my videos. Thanks for watching and bye bye for now.